Hello, welcome everyone to this session. I'm Nico from Ethereum, and today I get to talk to you about Skynode. What it is, what problems it solves, and how we built it. I'll take some time at the end to show you some of the cool things you can do with Skynode. But stay tuned for that. First, I want to start and I want to talk a little bit about the journey from a prototype to a product. The hurdles that you have to bypass to get there, and how you can use Skynode to accelerate your process to get there. I'm convinced that Skynode is the fastest way to get from a prototype to a final product. Let me take you through that journey. So in this audience, I'm sure a lot of people can relate to a desk that looks something like the picture in the left here. And that's a good thing. The first step to any product, PX4 based or otherwise, is a good proof of concept, right? We start connecting things, hacking things, wiring things together, and sometimes putting things on fire. We learn, we iterate, and eventually we come up with something that might be worth putting into a product. Most likely, as a next step, we're going to cram it into a drone and take it to the skies. Who doesn't love the excitement of a maiden flight of a first electric prototype? And then we start making it better, right? We build a second one, a third one, and pretty soon we start to deal with the harder problems. Some units work, others don't. Others work some of the time. We may have signal integrity or EMI problems or mechanical issues, classic system integration problems. So we start to make it more robust. We replace a wire harness with a PCBA here and there. We robustify things. We design the entire system. We really go very deep in productization. We do mechanical testing, stress testing, thermal testing, and so on. And slowly but surely, it starts to feel more real. I still get goosebumps these days when we receive a new PCBA out of the factory sometimes, and you're not quite sure whether it will work, but if it does, it's very exciting. So after a few more thermal meltdowns and psychological meltdowns, we finally get something to work. Now, just because it flies doesn't mean it's a viable product. We have to solve some tangible problem in the market. We have to differentiate our product somehow. So we start to think about payloads and payload integration. Maybe there's a thermal camera we want to integrate with. Maybe some other fancy sensor, maybe a LiDAR, or so on. So we can take care of the software integration for that specific payload. No problem. And then we think beyond that. When we have the data captured, what do we do with it? Maybe we want to geotag some images right on board, or maybe we want to upload them and process in a cloud somewhere. So we start thinking about online workflows. And then right on the back of that, maybe we want to think about managing a fleet, remotely updating vehicles, and monitoring the health of a fleet. How do we do all of that? It's a lot of work that needs to be done to really go all the way here. We've gone through this process with Skynode, step by step, and we have the scar tissue to prove it. So let me tell you a little bit about our journey. And in particular, I want to start off by showing one of the very, very first prototypes we built, proof of concept, actually, it's not really a prototype, of Skynode. So a long, long time ago, in a galaxy far away, our desks looked like this. So again, maybe a desk setup that one or two of you can actually relate to. So I want to point out a few things here. First one, in the center of our universe, there's a Pixhawk. I think I don't have to explain this part. Second, we want to add a little more sophistication to the system. We want to do more than just fly. Maybe we want to run some higher level applications about processing images on board or do video streaming. So we throw a companion computer into the mix. Then, of course, we have to connect it to. Typically, we can do that with a serial link. And depending on the applications we're running, on either side, pretty soon there's the first system integration challenge for us. So on the one hand, there's a real-time system. On the other hand, there's a non-real-time system. And pretty quickly, that serial link can become the bottleneck of our system. Not trivial, but we can do that too. Then we need to think about power management. We have to power everything. There's probably better and worse ways to do that. Ideally, we build in some redundancy to the system. Maybe if one power supply fails, another one can take over and so on. And then let's start to actually do useful stuff. We connect the payload. We worry about camera integration, geotagging of images, using information we retrieve from the FMU, and so on. A lot of software to write there. Easy peasy. And then we have to get our images somehow across the air to the ground. So we add some data links. And of course, our corresponding data link module on the ground side. And then how else would we display or interface to the user than with some ground control software? And then last but not least, I mentioned online workflows. So let's throw an LTE dongle into the mix. And voila, finishes our system. A lot of different components right here on the table. And they all need to work together just right to make it work. What's next? Well, let's go back to our roadmap. We have our proof of concept very early on, but we're really not there yet. From here, we have to start integrating that into more compact form factor. From there, we have to do a lot of testing, from thermal testing, EMI, signal integrity, you name it. A lot of stuff that needs to be done. Not to forget, eventually, if we want to manufacture that, we have to think about those types of problems. How do we test them? How do we make sure it doesn't fall out of the sky on the first flight? Or how do we ensure repeatability of our manufacturing processes? A lot of stuff to be done. And then, of course, the software to be written on payload integration and online workflows also needs to be kept up to date and maintained. And maybe we want to continuously grow the number of payloads we support and so on. So a lot of stuff to do, really, big tasks for us. But the good news is we've done all of that for you, and you can take full advantage of that right away. So on Skynode, we have an FMU V5X, state-of-the-art, right inside. Also, it tightly interfaces to a companion computer. And, of course, the power management is already integrated as well. In addition to that, an LT module to make sure we support online workflows out of the box. And with all that together, you could simply connect your data link module on the Ethernet port or your payloads and start using that really plug and play. I'll show you how that works later on. And of course, part of the package is all the software you need to run that. So from our beloved PX4, tested and QA'd by our team, to the software pieces you need running on the mission computer to handle camera integration and all the updates and so forth, as well as ground control software and a cloud solution coming with it. And of course, as a developer, I wouldn't be completely happy if I didn't get a way to play with a system myself. So there's SDKs that allow you to interface with the FMU, with the ground, with the suite, and everything else you would like. So that sounds really cool. So let's dig a little bit more into what's inside the orange box in just a bit more detail. So that's a very rough block diagram of what's inside. So on the left-hand side, we see the mission computer. It's actually a quad-core 1.8 gigahertz CPU with 4 gigabytes of RAM, 16 gigabytes of eMMC, and an integrated SD card. So a good amount of power to run plenty of overhead to run your own applications on top of the Ethereum software stack. And that connects over a serial link to the FMU. We have an FMU V5X equipped with triple redundant IMUs, and of course, exposing all the faces that you're used to from your Pixhawk universe, from the CANs to the I2Cs, UARTs, PWMs, and so forth. In addition to that, of course, we have power management integrated right into the system. There's a dual redundant power setup right in there. In addition to the serial link, there's also an Ethernet switch connecting the mission computer and the flight controller. You can use that to, depending on how you set it up, to increase the bandwidth between the two, or to interface with additional payloads or data links on the outside of Skynode. There's also a USB hub on there, exposing yet more interfaces you could use to attach certain payloads. And of course, the LTE module and a USB interface for developers, as well as a MIPI port for connecting cameras. So, a lot of tech details. I hope you're still here. That being said, I want to get to the most exciting part and show you a few things, literally hands-on, of how it works. So this is Skynode. To this day, I like picking it up, having it in my hands. It feels very nice and premium. It's definitely in the category of products that you like just by their exterior as well, similar to maybe an iPhone where you never throw away the box because it's so pretty. So it definitely has that sort of feel, and I love that to this day. So let me power it on. And the first thing we do from our PixHawk days when we power on a flight controller or an autopilot is we connect it to our laptop with a USB. So let me do just that. And then let me exit the presentation here real quick. And then, of course, we fire up our favorite ground control application, which in my case is, of course, AMC. And right out of the box, we get a connection to an autopilot and a setup that we're instantly familiar with. So if you've ever worked with a PixHawk, you're completely at home in this page. You have your airframe set up, your sensors you can calibrate, your radios, your parameters you change. This is really, this kind of feels like home to PixHawk developers. So that's a really cool thing. But as I mentioned, what we're actually connected to here over the USB is the mission computer, which is in this case just forwarding the Mavlink traffic to Ethereum mission control. And I think I can get that point across by showing you what payload integration really means to me. So I can pick any webcam, off-the-shelf USB webcam, as long as it supports the USB standard, the UVC standard. I can literally connect it up to Skynode and start using it right away. So there's a small adapter cable. Connect that here. Connect it to Skynode. And then, pretty much out of the box, I get video streaming. And what I mean by camera integration is really a lot more than just video streaming. I think you're not impressed by a video stream by itself. So let me show you what I mean when I say payload integration. That means, for example, you can also take pictures or go into settings and do things like changing brightness of the cameras or something like that. Maybe that's a little too dark. Okay, so, and the pictures, of course, they're also already available on the photo gallery right there. So let me go ahead and actually delete that again. It's not a pretty picture of me. So that's a really cool feature to me. And that, to me, really brings home the difference to a normal autopilot when you're working with Skynode. And this doesn't work with just the webcams. It works for all the payloads that we support. You plug them in and you get full camera integration right out of the box. Another very cool feature I would like to show you is how you can leverage simulation to test your systems. And that's actually incredibly easy to set up. So you can go into the vehicle setup, and as an airframe, you can select the simulation in hardware vehicle right there. And then you hit apply and reboot. And then when it does that, check it out. All right, it's going to tell me that it's running simulations right here. And as you can see here, it's simulating a GPS location, which is pretty far away from my Zurich location that I have right now. And now there's a simulation running that's telling the FMU that the sensors are actually producing meaningful data. And I can use that to run through the entire workflow. A few more parts that are part of that workflow, as I mentioned, Skynode has an LT module inside, so all I need to do is attach the LT antennas, and then my Skynode will also be online. 2 snaps. Okay. And now I have a pretty complete system. So let me do something fun. What if I go in here now? I plan a short mission. Let's start with a takeoff, 25 meters, I don't care, 16, something like that. Let me add a little waypoint somewhere here maybe. And let's take a picture at this waypoint, why not? And then let's add a second waypoint here. And let's take a second picture. Okay, and then we'll return to home. Cool, upload that mission, and boom, we can start it. Now what's happening in the background is that actually that flight will start going. So if you look at the bottom right, you can see the altitude increasing. Right now the multicopter is taking off, and pretty soon it will start flying towards waypoint 2, take a picture, fly to the next waypoint, and so on. In the meantime, I would also like to point out on the top right here, the LTE module, so we can see as I attach the LTE antennas, my Skynode has actually started being online. In addition to all the things that are running on Skynode, there's actually a small web server running on it that I can access over my browser and retrieve a whole lot of useful information. So you can just go to skynode.local and you access this web interface. And as soon as it loads, it shows you a bunch of useful information, like the serial numbers, the PX4 version, and the online status. So you can see that my Skynode is online. Now I can go into the suite directly with a link from here, and it will show me the vehicle page in the Aterian suite. Pretty cool. Check it out here. I can actually see that my Skynode is online. It reported to the suite less than a second ago. And if I scroll down, I can even see the current ongoing flight. Look at that. I click on the flight log, and I can see my vehicle flying through the simulation, uploading that log in real time as a simulation to the Aterian suite. Let me switch back to the suite. Here it's still going. And in addition to that, the simulation is as complete as taking the pictures. So we're in the air right now, and I can go to the photo gallery and look at the pictures that have been taken. And I can download the full resolution version of that, for example, and display the geotag information. In this case, that information is coming out of the simulation, of course. How cool is that? So you get end-to-end integration of the software stack, literally from the ground control side to what's running on the mission computer to the actual flight control and all the online workflows with the suite. And last but not least, I want to show you that I'm a happy developer because I can pull up a console and literally access my Skynode via SSH. And right there, I have all the options in the world, from deploying and interfacing with Mavlink using, for example, the Mav SDK. I can write an app and talk to the FMU, or I could access the camera images and so on. So that's pretty neat too. So I think that was a pretty quick rundown of some of the Lighthouse features around Skynode. And with that, I would like to stop this live demo right here and jump back into my presentation slide and start taking questions, maybe. Let's see. So there haven't been any questions yet, but maybe I can talk. Something that comes up very often is, when can I get Skynode? So actually, we have these units in stock available right now. We typically sell them as an evaluation kit. And that's basically all the components you need to get started right away, from power modules to GPS and some data link modules. And right out of the box, you get beautiful instructions on how to set everything up, how to get up and running. Okay, we have questions coming in now. What's the Skynode price? So that depends heavily on which configuration you get. So typically, Skynode is meant as an evaluation platform in the Skynode Enterprise variant. So we sell it in the full evaluation kit, including all the peripherals. And you can get a quote for that online at auterion.com/Skynode. And as you scale up your production, you go into higher quantities, you typically want to move beyond the orange box and use the Skynode OEM variant, which is much more cost effective. And already in the tens, it can go for around $1,400. And really in the triple digits, it can dip under $1,000. So I guess you won't answer, but I'll give it a try. How much is it? Okay, I think that's a duplicate question that I just answered. What's the estimated cost of the module? Another duplicate. Will MAV SDK work, or is there an SDK that Auterion provides? Yes, MAV SDK works right out of the box. You can use it and deploy applications directly on Skynode. Do you get Auterion Suite with Skynode? You do, absolutely. The basic plan is for free. You also get, I'm not sure, I think a 1-year subscription of the mid-tier for a year. Don't quote me on that, I'm not 100%. Is the LTE module available in the APAC region? How about regulation for the module? That's a great question. So actually, right now we have 2 variants of the LTE module, one for the North American regions and the LTE bands there, and one for the EMEA region, Europe, Middle East, and Africa. And there's an APAC variant that we actually are evaluating right now. Availability is a bit tricky, but we're working on that. What else? Is it a subscription price, or can we just buy Skynode to play with? So you can just buy Skynode to play with. So when the software licenses run out, you're free to not renew those, of course. And there's a perpetual license to keep using the software on that it ships with. You just will stop receiving updates. Now, hi Nico, just took delivery of a Skynode-enabled FreeFly Astro. Wanted to ask if AMC itself is modifiable. It is a custom implementation of QGC, yes. Fundamentally, that's correct, yes. Auterion Mission Control is based on QGC, and it basically has a polished UI on top of QGC. It is modifiable. I not that much in the loop on how we do everything on the AMC side, but we plan to provide SDKs to allow you to develop on top of that. In addition, you can enter SLA agreements with us and get source code access to that. Those are definitely open options. Is there some cloud fleet management UI you can demo? Well, to some extent. So I could go back into Auterion Suite and look at the simulations here. But maybe those logs are coming from the simulation I just ran. So, for example, there's the vehicles page, which right now I've just selected the specific vehicle, and we can see the flights that it has completed. There's also pages for all the flights. You can actually spin up simulations running purely in the cloud. I don't want to go too much into detail on the Auterion Suite because I think that's a little bit off topic. But you're welcome to reach out over success@auterion.com, for example, if you want to receive more information on the Auterion Suite. Which parts of the SDK are open sourced? So the most open source way of interacting with Skynode will be the Mav SDK. So that's the go-to answer right there. There's also APIs to talk, to interface with the suite. I believe those are public. Okay, a lot of questions coming in. How am I doing on time? Nico, can you explain the difference between Skynode Enterprise and Skynode OEM? I already have evaluation kit. Okay, so that's a great question. I love it. Skynode Enterprise is this beautiful, shiny orange box that I love so much. And it is meant to be the quickest way to get anything to work. It's very robust, it's very reliable. But as you scale up your production, it may not fit the tightest form factors of your drone. And it has a fairly large heatsink because of the powerful mission computer that's doubles up as the enclosure. So if you're doing a tight vehicle integration, you can go to Skynode OEM, which is basically the Skynode without its enclosure. And then you could take care of the heat situation by maybe sinking the heat through your chassis or something like that. You could even go a step beyond Skynode OEM and get the reference design, at which point we basically tell you how to build Skynodes, and then you can go beyond fitting the actual OEM into your vehicle, but you could maybe change some connectors or some mounting holes and things like that and make it fit even tighter spaces. Great question. What type of support do you offer with Skynode? So, of course, we have our customer support, which will answer all your technical questions in and around Skynode. We also have some of the best PX4 experts in the world in-house. So if you struggle with some more generic PX4 issues like PID tuning or setting up a vehicle that you're new to, then we definitely have those capabilities in-house, and we can offer professional services to help you out with that as well. But that's not, strictly speaking, part of the complementary Skynode customer support. Can you describe Skynode's power management features in more detail? Of course, yes. Skynode has two power inputs. They actually take about 5.2 volts as inputs, and they're completely redundant, and they show up as two batteries. They're powered externally from a power module that ships with Skynode. It's compatible up to 6S, and it also measures all the current being consumed by both batteries. So if either one of the two batteries fails, Skynode will immediately know about it and can take according action to that. We're actually also in the process of developing a higher voltage power module that supports up to 12S and 100 amps. So that's to come very soon. And yeah, I hope that answers this question. What operating system do you run on the companion computer? It's basically based on Ubuntu. Yeah. Thanks for the great talk and demo. Is the mission computer you propose protected in any way against security attacks? So that's a great question. So we actually have on the flight management unit, we're right now in the process of rolling out a secure bootloader that will ensure integrity of the binary being launched on the most safety critical piece of Skynode, which is the flight management unit. In addition to that, all our data link modules, for example, use AES 128 encrypted communication with the secure pairing protocol that enables a secure connection between the two. Going beyond that right now, that's a bit work in progress. What happens when you fly on areas where LTE is not available? Great question too. Depends on how you use LTE, of course. Typically, when you're, for example, if you're using the LTE only for fleet management and log upload purposes, that won't really break your operations. The logs will just continue and finish uploading when you're back in reception. So that's not an issue. If you're using LTE as your command and control link, which is somewhat a non-default way of setting up your system, but it's possible, then of course the vehicle would lose the command and control link and initiate a return to launch maneuver. Can we feed vision positioning to it and disable GPS? Absolutely. So as long as you know how to take care of integrating all that, you could easily run that sort of stuff on the mission computer directly, maybe interfacing over the USB with your cameras, run it on there and communicate to the FMU. Some integration work probably left to be done, but in theory, there's nothing standing in your way on the technical side. Cool. I think I've answered all the questions. There's one more coming in. Nico, besides the customer support, do you have training areas to learn about the Autopilot and become distributors in Latin America? We're running a drone school. A drone school, that's really cool, very exciting. Actually, so I would love to point you towards our docs. We spend a good amount of time polishing that, and I think that could be a good foundation to start a training program. We're also ramping up some training schemes in other areas. So if you want to go beyond what's publicly available on docs.etarian.com, feel free to reach out to us. And yep, with that, I would like to conclude my presentation. Thank you very much for your attention, and I wish you a great day.